All right, let's look at the homework 2.8, problem number 9. All right, so we want to find the derivative of this given function here, g of x equals x to the 2/3 power. All right, so let's do that. All right, so we want to find g prime of a is equal to, all right, so you have a limit as h approaches 0, as usual, right? Then we have g of a plus h. So you have, we see x, we put a plus h there. So we have a plus h to the 2/3 power. Minus g of a would be a to the 2/3 power, right? And then all over h, right? So we have that. Right, so in order to simplify this, so we have a cube root. In order to get rid of cube root, this would be the trick we can use, right? So we already have something minus something here, so a minus b form. So if we have a squared plus ab plus b squared, we get to cube each term. So I'm going to do that here. So multiply top and bottom by, right? So this guy square would be, so maybe I have a plus h to the 2/3 power squared would be 4/3 power, right? Plus this guy times that guy, so you have a plus h to the 2/3 power times a to the 2/3 power. I know it looks really ugly, but this is going to simplify quite nicely. All right, then b squared. So this guy squared would be a to the 4/3 power. All right, so I'm going to do exactly the same thing to the denominator. So you have quantity a plus h to the 4/3 power plus a plus h to the 2/3 power times a to the 2/3 power plus a to the 4/3 power. Right, so if you multiply out, you're going to get this. So you have a limit, let's see, wrong color there. So you have a limit as h approaches 0, right? And then here, so we're going to have, we get to cube this, a cube, so the cube root is gone. So you have a plus h squared by minus, right? So we get to cube this, so you have a squared on top. And on the bottom is going to be a little bit ugly. We just have to copy that. So you have quantity a plus h to the 4/3 power plus quantity a plus h to the 2/3 power times a to the 2/3 power plus a to the 4/3 power. So just to copy that. All right, but we can simplify the numerator this way. So if you multiply this out, you see that you're going to get a squared plus 2ah plus h squared. All right, so we can cancel a squared minus a squared. And what you get is this. So you have a limit as h approaches 0. Right, the numerator is, let's see, the numerator is those two terms, both has h in it. So I'm going to pull out the h, right? So 2ah becomes just a 2a, and the h squared becomes just going to be h there. Right, denominator unfortunately stays exactly the same. So you have h times quantity a plus h to the 4/3 power plus quantity a plus h to the 2/3 power times a to the 2/3 power and plus a to the 4/3 power. Right. Then we can cancel h on top and h on the bottom. Right. Then we're going to send h goes to 0. So h is going to approach 0. So this is going to disappear. This h is going to disappear. That h is going to disappear. So what's left is going to be, you have a 2a on top, and then you have a to the 4/3 power plus a to the 2/3 times a to the 2/3, so you have another a to the 4/3 power plus a to the 4/3 power. All right, so we have 3 of those on the bottom, so you have a 2a over 3 times a to the 4/3 power. All right, then we can cancel a and 4/3, so it's going to be 1/3 left over. So we get, it's just going to be a 2 over 3 a to the 1/3 power. Or you can use a cube root if you want. All right, so let's type it in. That's not it. Here. All right, so we have 2 over 3 times a to the 1/3 power. All right, so we have, let's see, get rid of that. All right, let's check the answer. All right, I came back and looks like we got part A correctly. All right, let's move on to part B. I illustrate that y equals 2 to the 2/3, x to the 2/3 power has a vertical tangent line, right? So you can see that here, x to the 2/3 power is going to be an even function because there's a square there, right? So you can see that this is not a picture of an even function. This is not a picture of even function. This is not a picture of even function. So by just knowing that the function is even, and then the picture should be this one here, right? Then it would have a vertical tangent line at the origin, and you can see that the slope is, here, so slope of the tangent line on the left is negative, and as it gets closer to 0, it's more negative and more negative, more negative, and eventually it becomes negative infinity. And if you're coming from the right, slope of the tangent line is actually positive, and then it's as it gets close to 0, the origin, slope is more positive, and eventually becomes a positive infinity, which means that you would have a vertical tangent line there. Right? So that's why the picture is that one, and none of the other 3 have anywhere close to that. All right, so this is it. All right, oh, actually, so this is it. All right, let's check the answer. All right, it came back and looks like we got the graph correctly. All right, that's it. I hope that this was clear.